Hello and welcome. In today's lesson, we're going to be talking about how to find missing sides of right triangles using trigonometry. In our last lesson, we talked about sine being the ratio of the opposite leg over the hypotenuse. We talked about cosine being the ratio of the adjacent leg over the hypotenuse. And we talked about tangent as being the ratio of the opposite leg over the adjacent leg. So today we're going to talk about how we can use those ratios to help us find missing sides. If we know an angle of a right triangle and one of the side lengths, we can find everything else we need to know. The first thing we'll do is we'll set our perspective to that 55-degree angle, and we'll look at what information they've given us on the triangle. So if we look at where X is, right, it is the leg that is opposite of the 55-degree angle. And the 20 is the adjacent leg to the 55-degree angle. We see there's no information given to us on the hypotenuse, so we wouldn't be able to use that piece, right? So we're looking for the ratio that uses opposite and adjacent. If you go up to the ratios we talked about, tangent is our one that uses opposite and adjacent. So we will set up tangent. So the tangent from the perspective of the 55-degree angle is the ratio of the opposite leg, which is X, over the adjacent leg, which is 20. So now we've set up an equation. To solve this equation, we just need to multiply both sides by 20, and we'll be able to solve it out. 20 times the tangent of 55 is something you'll be able to type directly into your calculator, and let's round to the nearest tenth. So 20 times the tangent of 55. Rounded to the nearest tenth, this gives us an X value of 28.6. Now, if you type that into your calculator and you got a totally different number, you might be in the wrong mode. Right? So check your settings, look at your mode. We want to be in degree mode because these angles are given to us in degrees, not radians. All right, so make sure you are in degree mode if you got a number other than that and you typed exactly that into your calculator. Get it into degree mode and you'll get the right number that time. All right, let's take a look at the next example. We start the same way. We want to set our perspective to the angle that they gave us. From the perspective of the 72-degree angle, when I look at the 80, it is the leg that is opposite of 72. X is across from the right angle, so we know it's the hypotenuse. So we're looking for the trig function that works off of opposite and hypotenuse. So we would choose sine. So I will set up my sine ratio. Sine from the perspective of the 72-degree angle would be equal to 80 over X, opposite over hypotenuse. Now you'll notice that this equation is a little bit different than the last one. On the last one, X was in the numerator. On this one, our X ended up in the denominator. So to solve, this is actually going to take 2 steps, right? When I multiply both sides by X to get it out of the denominator, cancels here, I get X times the sine of 72. So we got it out of the denominator, which is a good first step, but we haven't solved for X yet. So from here, we would need to get X by itself by dividing both sides by the sine of 72. So dividing by the sine of 72 on both sides. That's going to cancel out the sine of 72 on the left, and now we have X equals 80 divided by the sine of 72. That is something we can type straight into our calculator and get an answer for. All right, so try that for me now. If you're in degree mode, 80 divided by the sine of 72, rounded to the nearest tenth, gets you 84.1. And that would be our final answer for that particular problem. Let's take a look at number 3. First thing we always want to do when we're solving for missing sides using trig is figure out where we're going from. Set your perspective to the 24-degree angle, and then look at the pieces that you're given. This time, we can see x is the adjacent leg, and 283 is our hypotenuse, right? Remember, the hypotenuse is always the one across from the right angle. So if you look up at our trig functions, we're looking for the one that works off of adjacent and hypotenuse. So this time we'll be using cosine. So I would set up the cosine from the perspective of the 24-degree angle is equal to x over 283. Right? This time we ended up with a number in the denominator, just like we did on number 1. So it's only one step to solve when that happens. Multiply both sides by 283. Right? So 283 times the cosine of 24 is something you can type directly into your calculator and get an answer for. So 283 times the cosine of 24. Right, we've been rounding to the nearest 10. We will keep doing that. This tells us x is equal to 258.5. And that would be our final answer. So we looked at two different things here. Well, we looked at a lot of things. We used all three trig functions, right? And there's really, once you set up your trig function, there's only two types of equations you'll end up solving. If you have a number in the denominator, like we had on number 1 and number 3, remember it's just one step to solve. Multiply both sides by that number, and you can get something that can be typed right into your calculator. The only other scenario you'll see is if x ends up in the denominator when you set up your trig function. That's what it's two steps to solve. You multiply both sides by x to get it out of the denominator, then you divide both sides by your trig function to get something that you can type into your calculator. So once it's solved for x, it looks like 80 divided by the sine of 72. So remember, if x is in the denominator, you will always end up dividing by the trig function to get your final answer. Right? Let's look at one more example together on the next page. Let's see. Let's take a look at number 1 together. Set your perspective to the angle they gave us and look at what pieces we have. X is opposite, 41 is the hypotenuse. So thinking about our trig functions, remember sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So for this one, we would definitely be using sine, opposite over hypotenuse. So I would set up sine from the perspective of 34 equals x over 41. Since we have a number in the denominator, it's going to be one step to solve. Multiply both sides by 41. 41 times the sine of 34 can be typed directly into your calculator. This page is telling us to round to the nearest tenth, so let's see what we get here. 41 times the sine of 34. That gets me 22.9 for my final answer. We have time for one more problem, so let's look at two together as well. The first thing we're going to want to do is set our perspective to our angle. 40 is opposite, x is adjacent. The trig function that works off of opposite and adjacent is tangent. So I would say tangent from the perspective of 46 equals opposite over adjacent would be 40 over x. So this time x is in the denominator. Remember, that's going to be two steps to solve. Multiply both sides by x. X times the tangent of 46 equals 40. That's not solved out all the way yet. That's why we have one more step. We need to just be x equals when we're done. So the tangent of 46 is what we're going to divide by on both sides. That cancels out on this side, so the x is all by itself, and we are left with 40 divided by the tangent of 46, which can be typed right into our calculator. 40 divided by the tangent of 46. Rounded to the nearest tenth, that's going to get me 38.6. And that would be my final answer. So we've got an example here where we multiplied and another example where we divided. Remember, if x ends up in the denominator, you will always end up dividing by your trig function. All right, that should be enough to get you started and to try the rest of our practice problems. Have a great day.